Hello everyone. Let's going to discuss in this class about the steam turbines, which we have completed about the hydraulic turbines and the governor system we have discussed in the last lecture, which I have uploaded. Now we are going to discuss about the steam turbines. Steam turbines simply you can see that it simply converts stored energy of high pressure and high temperature steam into rotating energy. Okay, which in turn converted to electrical energy by the generator. As we already have learned about and study about what are the steam turbines, simply both in the coal generated power plant and mm, in the nuclear power plant. In the nuclear power plant, the functioning uh, of the second half you can say, because for the first half we are generating the steam by using the coal, and in the another type of technology we are generating the steam by using the nuclear energy, by using the uranium 235. Okay, uranium. So the source is simply the steam for rotating the turbines. Okay, so we have to discuss about the turbine, so we are not going in detail. We just have to know about the steam which is being generated. All right, so the source for the boiler supplying the steam may be a nuclear reactor or a furnace fired by the fossil fuel, and this can be coal, gas or oil. Mostly it is coal. Okay, in very few occasions we use gas and the oil. All right, as in India also we all know about that the total generation in India at present is approximately 60% from 60%, around 60% from coal. Okay, from coal. So major portion of the generated electrical energy at present in India we have from coal. Okay, so you can understand the how much we depend upon this. Okay, so let's move on. So the variety of steam turbine configurations have been built depending upon the unit size. Okay, ये आपके पावर प्लांट के साइज पे भी डिपेंड करता है. We have different sizes of the steam turbine, from a few megawatts to several hundred of megawatts. Okay, after in NTPCs we have approximately 500 megawatt unit and 200 megawatt unit. All right, and in other power plants also we have 50 megawatts, 40 megawatts, like that. Okay, so the turbine, अब जितना ज़्यादा मेगावाट का आपका प्लांट होगा, एक पर्टिकुलर यूनिट होगा, द साइज ऑफ द टर्बाइन डिपेंड्स अपॉन द unit size. Okay, and the steam conditions. Okay, steam conditions. So they are normally consist of two or more turbine sections coupled in series. They consist of two or more turbine sections coupled in series. How they are coupled in series and how they are combined, okay, we will see in near future in the next slides. So each turbine section consists of set of moving blades attached to a rotor and set of stationary vanes. Now you can see that each turbine section consists of set of moving blades attached to the rotor, because we have different sections of the turbine. We have the high pressure turbine, in that we can have the intermediate pressure, you can say, pressure turbine, and low pressure turbine. In a single set we have. ठीक है, सबसे पहले जो हाई प्रेशर आता है वो पहले उस टरबाइन को रोटेट कराता है, फिर उससे कम प्रेशर हो जाता है तो रीहीटर के थ्रू अगेन वी गेट give the same steam into the intermediate pressure turbine, and then after that we give into the low pressure turbine. So we utilize completely, we try to utilize in full that the steam which is being developed by the power plant. Okay, so let's move on. So the moving blades are called buckets. And the stationary vanes through which the steam is moving from the nozzles. Stationary vanes from nozzles in which steam is accelerated to high velocity. They are the nozzles. They are designed in different ways. Just like this also you can say that we have a neck portion. तो जो स्टीम आती है तो वो यहाँ से जाती है, तो इसका प्रेशर ज़्यादा बढ़ जाएगा क्योंकि ये नेक पोर्शन है, आप जानते हैं. इसका जब क्रॉस सेक्शनल एरिया कम कर देंगे तो प्रेशर जो आ रहा होगा वो प्रेशर फिर बढ़ जाएगा यहाँ पर, ठीक है। सो द काइनेटिक एनर्जी ऑफ दिस हाई वेलोसिटी स्टीम इज कन्वर्टेड टू शाफ्ट टॉर्क, ओके। तो वो जो बहुत हाई वेलोसिटी स्टीम आती है तो इट सिंपली कन्वर्टेड इनटू द शाफ्ट टॉर्क। दिस इज द वेरी दिस कॉन्सेप्ट यू मस्ट हैव स्टडीड अबाउट। सो द टर्बाइन विद मल्टीपल सेक्शंस में बी tandem compound and cross compound, okay, tandem compound and cross compound. What is tandem compound, what is cross compound, we are going to study. So the cross compound have greater capacity, improved efficiency, but it must be more expensive. Capacity बढ़ जाएगी, efficiency बढ़ जाएगी, but that cost is also going to increase, okay. Whereas in tandem compound turbines, all section on one shaft with single generator. टेंडम कंपाउंड टर्बाइन के अंदर होता यह है कि सारे सेक्शंस मींस हाई प्रेशर, ओके, इंटरमीडिएट प्रेशर एंड द लो प्रेशर टर्बाइंस आर ऑन द सिंगल shaft and they all are connected to the single generator, okay. So we have 4 set of valves in the turbines. To operate that we have 4 set of valves. One is the MSV, main inlet stop valve, RSV, reheater stop valve, okay, CV, control valve, and IV, intercept valve. How they are going to work and what are they, let's see. So the utility and the function of these valves are simply MSV and RSV. So main inlet stop valve and reheater stop valve, okay. So main and reheat stop valves come into action during emergency trip conditions and are not used for speed and load control, okay. They come in emergency trip condition. Emergency trip condition में इन दोनों का इस्तेमाल किया जाता है. They are not used for speed and load control. They are not usually modeled in dynamic conditions, all right. Whereas CV, control valve, it modulates steam flow through turbine for speed control during normal operation. Normal operation के दौरान इस valve के through we just control the load and the speed, all right. So they are under the control of governor. Governor के through इसको control किया जाता है, okay. So the control valve are housed in the steam chest, okay. The steam chest holds substantial amount of steam, okay. Steam chest hold substantial amount of steam. So the time constant of its operation is around 0.2 to 0.3 second. In this small time it is just operate, all right. तो इससे हम कंट्रोल करते हैं स्पीड भी और लोड भी, वॉट एवर द अमाउंट ऑफ स्टीम वी आर गोइंग टू गिव एट द इनपुट थ्रू द कंट्रोल वॉल्व, that much output we are going to get, and it's simply steam and load both are depend upon the same thing, because how much the speed is going to increase of the turbine, the same in the same proportion you are going to get the output from the generator, all right. Now intercept valve. Intercept valve is what? These are used for over speed control, ठीक. In the event of over speed, turbine safety requires that the steam input be reduced rapidly, which will in turn reduce the मैकेनिकल पावर, जिससे फिर मैकेनिकल पावर भी उसमें कम हो जाएगी. जैसे अगर हम एकदम से स्टीम कम कर देंगे, मैकेनिकल पावर आउटपुट फ्रॉम द जनरेटर from the turbine is also going to get reduced, okay. So they control input to the intermediate power turbine, pressure turbine, and the low pressure section, okay, which together generates 70% of the total power. This you can understand that intermediate pressure and the low pressure turbine develop together about the 70% of the total power, okay. Now you can see over here that the tandem compound steam turbine, the model of that. Now the tandem compound, we have told you earlier that it is connected to a single generator. So single generator is there. So you can see that from the boiler the steam is coming. Main inlet stop valve is there. Control valve is in series with that. So this is, they are going, and the steam is going first of all in the high pressure turbine, all right. After the utilization in the high pressure turbine, this moves to the crossover to the low pressure turbine, okay. So low pressure turbine are here. both the high pressure turbine and the low pressure turbine are connected to the same shaft and thus to the same generator, and it is giving the output power to the power system. All right, so the steam coming out of the low pressure turbine condenses and a closed cycle is there. You have studied earlier. This is a non reheat. We didn't find any reheater in this particular model. All right, now move on. We have single reheater over here. Okay, single reheat. Again, the same procedure is over here. We have the main inlet stop valve, then control valve. After the control valve, through this the steam is coming and is going in the high pressure turbine. Okay, after the high pressure turbine, the steam coming out of the high pressure turbine is going through the reheater. It increases its temperature and the pressure, again reheated. Then this is what IV is here. Okay, and RSV is over there. RSV is reheater stop valve. So this is the reheater. So reheater stop valve is there. Okay, and in series with it is intercept valve. Okay, IV. So after that it is moving in the intermediate pressure turbine. After intermediate pressure turbine, the exhaust steam is going on through the crossover, then to the low pressure turbine, and then after that it is going to the condenser and the closed cycle move on. So it is connected to the generator to the power system. All right, so we have single reheater over here. Okay, so this is the another type of model for the tandem compound. Okay, so single generator is over here in both the sections you have seen. So this is the tandem compound steam turbine. Now it is also, we have the single reheat over here. Okay, so in this you can see that we have main inlet stop valve, control valve, high pressure turbine is there. After this you can see that we have single reheater over here. Okay, single reheater over there. So it is coming connected to the intercept valve, reheater stop valve, and going to the intermediate pressure turbine. After that it is connected to the crossover, and through the crossover we have two low pressure turbines over there. Okay, and after that it is going to the condenser and so on. So this is the another type of model, and again this is a tandem compound, single generator is being connected. Now the next model is in which we have double reheater over here. A double reheater, you can see that we have main stop valve, control valve, we have very high pressure turbine. Okay, ultra high pressure turbine are there. So we have very high pressure turbine over here. Okay, after that one reheater is connected. Again we have the valves in between, then comes to the high pressure turbine. After the high pressure turbine, the same procedure is there. We have again reheated over there. Okay, then going to the intermediate pressure, and after that we are giving to the low pressure turbine. Okay, we have just this much, ये यहाँ पर added है. ठीक है, very high pressure we are reheating, then to the high pressure, then again reheating, we are giving to the intermediate pressure, then through the crossover we are giving to the low pressure turbine. Okay, so this is a double reheat model. Okay, now next come to the cross compound steam turbine. Cross compound steam turbine, in that cross compound steam turbine we have already told you that we have, it consists of two shafts. Okay, दो shaft होते हैं और दोनों shaft आपके अलग अलग जनरेटर से कनेक्टेड होते हैं. तो वी आर गिविंग द आउटपुट टू द टू जनरेटर्स. मतलब अब आप देख सकते हैं कि व्हेन वी हैव two shafts, two generators, so the cost of the generator is going to increase, but we are getting the more efficiency. Okay, so let us see this model in which we have single reheat. Okay, single reheat. So from here you can see that we have MSV, we have control valve, high pressure turbine is there. After the high pressure turbine, we are through the reheater, we are giving to the intermediate pressure. Both the high pressure and the intermediate pressure turbine are connected on the same shaft and through to the same generator. But after the exhaust, okay, after the steam exiting from the intermediate pressure through the crossover, we are giving it to the low pressure turbine, but this low pressure turbine is connected to one separate generator. Okay, so two generators are over there, G1 and G2. Okay, high pressure and intermediate pressure turbines are connected to the G1, whereas the low pressure turbine is connected to G2. Okay, now Now again you see that we have high pressure turbine is over here. Okay, high pressure turbine is over here, and thus just see this what we are doing over here. यहाँ से आप देख सकते हैं कि रीहीटर यहाँ लगा हुआ है. रीहीटर के बाद में इंटरमीडिएट प्रेशर और वहाँ पर क्या था, हाई प्रेशर HP और प्लस IP था. LP लो प्रेशर अलग था. यहाँ पर हाई प्रेशर प्लस लो प्रेशर है और इंटरमीडिएट प्रेशर प्लस लो प्रेशर है टू द सेम सिंगल जनरेटर G1, and this is connected to G2. Here this G1 is connected to high pressure and low pressure, and G2 is connected to intermediate pressure and the low pressure. Okay, so from here you can see that through the single reheat is over there, but the combination is such that we are having after the intermediate pressure through the crossover. So this crossover is connected to two low pressure turbines, and in which one low pressure turbine is connected to the high pressure turbine and one low pressure turbine is connected to the intermediate pressure turbine. So with the combination of both of them is connected to one generator, and connection of intermediate pressure and low pressure turbine is connected to generator number 2. Okay, now this is the third model of cross compound steam. Here you can see we have MSV CV, we have very high pressure turbine. Okay, very high pressure turbine. So you can see that after very high pressure turbine, the steam is going to the reheater. Through the reheater, it is moving to the reheater wall, okay, intercept wall, and then to the high pressure. After the very high pressure, we are going after reheating to the high pressure, and after the high pressure, you can see that the steam which is coming out of the high pressure, again it is getting reheated. Okay, again it is getting reheated and going to in this direction and in this direction. Okay, in both the directions it is going to intermediate pressure turbine, one intermediate pressure turbine which is connected to very high pressure turbine, and the second intermediate pressure turbine connected to high pressure turbine. Okay, plus this after this intermediate pressure turbine, the steam coming to the crossover from both the intermediate pressure turbine to the common crossover, and then again going to two low pressure turbine. Okay, so here we have the combination very high pressure plus intermediate pressure plus low pressure turbine connected to generator number 1. Okay, whereas second combination is this high pressure plus intermediate pressure plus low pressure, it is connected to generator number 2. Okay, so we are having the two combinations for G1 and G2, and where the double reheating we are using. Okay, so these are the different combinations of the steam turbines being used in the thermal power plants. Okay, so up in this lecture only up till now. On the next lecture we will move further in the same topic of steam turbine. Okay, thank you, thanks a lot.